Hello, Venkat. Can you hear us?
Hi.
Hi.
Greetings. How are you?
Yeah, we're fine.
Very good. Excellent. Are you able to see my screen?
Yeah, we can see your screen
Okay.
and your little video stream as well. Yeah.
Okay. Awesome. Thank you.
Right. So I see people are still joining in. We have around 85 people in. We'll start in about 5 minutes.
That's good.
Okay.
Thank you.
Venkat, we were actually wondering how you're doing the talk at this time. Are you in India by any chance?
No, I'm here in Denver area, Colorado.
Oh, wow. It's really early there then.
It is.
Or
It is.
late.
Yeah, about it's going to be a little bit before 3 a.m. right now, but
Oh,
I'm
wow.
used to it. Yeah.
Thank you. Thank you so much for doing it at this time.
Oh, thank you. Absolutely, no problem. So there is a chat window here, but there's no separate Q&A window, right?
No, so we will do Q&A through the chat window itself.
Yeah, sounds good. Yeah, I'll keep an eye on the chat.
Venkat, while we wait for others to join, I noticed you teach at the University of Houston, and I've heard such incredible stories about how the university was turned around. I believe it was Miss Khator who did that, or she brought in a lot of thought leadership, right?
It is. It is. Yeah, definitely. Yeah, yeah. They're trying to really become a tier one institution, so doing definitely really good things.
That's amazing.
Right, a lot of people are joining in. So Venkat, we had prepared two introductory slides. So initially I'll share my screen, and after that you can take over. Does that sound good?
Sounds good. Perfect. Thank you.
Okay. I'll share my screen.
Hardik, we can let people keep joining, but I'll just get started with a quick introduction. So Venkat, thank you so much for joining early and testing this out. We really appreciate it. And thank you everyone for joining this session, and Happy New Year to everyone. We're really, really happy to have you here for the first talk of the year, and it's going to be a really exciting one, that too. Um, since a lot of you may be joining us for the first time, a very quick introduction. I'm Rushali. I'm one of the organizers of this community, and I'm the founder of Incubite. We started this community last year to basically help spread awareness and skill around practices, values, and principles in software development. And we really take software craftsmanship to heart, and which is why we're inviting several experts to talk about various technical and cultural topics as it relates to software development. A lot of our past events are available on our YouTube channel. And Arohi, if you can post the link to our YouTube channel and our events page here so people can go there if they want to take a look at our past events. Um, our topic today is probably one that a lot of you who may be working with object-oriented or structured programming paradigms might have been exploring these days, right? And that is transitioning to functional programming. We're really excited to have Dr. Venkat Subramaniam here. He's an expert in this field, and he'll be talking to us about it today. Um, Venkat is an incredible trainer. He has authored books on agile practices and various other topics like Kotlin or functional programming and many others. He has inspired many, many people across the world to improve the quality of their code and how they do software development. He's won the Java One Rockstar Award 3 years in a row, and he himself is a Java champion for his contributions to the software development best practices. You're right, he does not need an introduction at all. So with that, Venkat, thank you so much for joining us today. The stage is all yours, and we're really excited to have you here.
Thank you, Shirley. First, I want to thank for all the efforts Hardik and you and everybody else has put in to organize this. I want to also say thanks to everyone who took the time to join. So let's get started. Before we dive into the topic really quickly, the best time to ask questions are make comments is anytime you have a question or a comment. So please don't hesitate. Please don't wait till the end. Anytime is a good time for questions. Post them on the chat, and we'll get to it fairly quickly. Just in case I miss a question because it kind of flows through in the chat, don't hesitate. Just post it again, and I'll be more than happy to respond to it. So with that said, let's get started. A quick confirmation: are you able to see my screen at this point? Awesome.
Yep, we
Excellent.
can see.
Thank you. Wonderful. So let's get started. So what I want to talk about is, how do we really refactor to functional style? Let me pause a little bit and emphasize that word, refactoring to functional style. I want to really start with that emphasis. We're not in a competition. So don't force yourselves to write in a particular style. We don't have to prove anything to anybody. And that is one of the reasons why I want to really emphasize the word refactoring here. So I often tell my developers, go ahead and write the code. I'm a big fan of this one principle I like to follow, which is make it work, and then of course, make it better real soon. So the goal really is to develop working software which is relevant and valuable for the business. So if you're really good at writing code in imperative style, go ahead and write it in imperative style. We don't have to prove to anybody that we can write in a particular style. But what I would always emphasize is have a fairly decent amount of automated testing around your code. And when you do, once the code is in place, it serves the need, you can take the time to refactor and modify the code for better readability and also better maintainability. And one way to achieve that is to really look at a functional style. So the question, of course, to ask is, why do we want to really write the code in a functional style? And the reason really comes to understanding the power of the different styles and when we may want to use one over the other. When it comes to imperative style of programming, let's talk about that really quickly. So imperative style is where we tell what to do and also how to do it. So in other words, we need to put our effort in not just the details of what we want to accomplish, but we have to narrate every single detail as to how we actually do it. Well, imperative style is very familiar to a lot of us. I spent a few decades programming in imperative style before I even looked at functional style. So a lot of us are really good at writing code in imperative style. But unfortunately, though, one of the problems is imperative style is packed with accidental complexity. So when it comes to complexity, there are two kinds of complexities we often have to deal with. One is the inherent complexity, which is the complexity from the problem domain, and the other is the accidental complexity that comes from the solution that we often choose. And when we deal with accidental complexity, it becomes hard to understand, hard to maintain the code. So it may be easier for us to write it, but it's often really hard for us to understand and maintain it, especially for other developers, but even for ourselves after a few weeks after writing the code, it can become really hard. On the other hand, we can look at what's called the declarative style of programming. So declarative style is really a different style of programming where we tell what to do, but not how to do it. So we don't focus on telling how to do something. We rely on underlying libraries of code to get things done. So the code becomes a lot expressive. And by nature, declarative style in general has less accidental complexity. And this is one of the reasons why we want to really refactor into a declarative style. But you wonder, then why do we really talk about functional style of programming? Well, the reason we talk about functional style of programming is that functional style is actually declarative style plus the use of what are called the higher order functions. So in other words, you can say every functional style code is also declarative. And that is one of the really nice things about functional style of programming is it's declarative, and as a result, it contains a lot less really accidental complexity in general. So that is one of the powers that we get from using the functional style. But of course, what really is the idea of really higher order functions? Well, higher order functions is really where we can pass functions to other functions. And so, in other words, rather than just passing data to functions, we can also pass functions to functions. Let's think about this a little bit, if you will. Let's say we're sitting around a dinner table and having a good conversation, and I might lean over to you and say, could you please pass that bread over to me? And you may take the bread and give it to me. Well, I asked for an object bread and you gave me the bread. So we pass these objects around. But on the other hand, as the dinner conversation goes over, rolls over, we may talk about some food that you really like making. And I may ask you, do you mind giving me the recipe for that food? And you may say, oh, sure, I'll be happy to. And you scribble on a little piece of paper and you hand me over a recipe on how to make that particular food. Now, notice what you gave me is an instruction as to how to make that food. So in other words, you're passing around not an object, but really a function. So in other words, you can pass objects around, but you can also pass functions around. And that's where the higher order functions can receive functions, not just objects. Well, we, of course, when we program in functional style, we favor immutability. But why do we really favor immutability? Not because it's fashionable, it's really important for correctness and performance as well. But one of the key essential parts of functional programming is this idea of functional composition. So functional composition is where we can compose functions and we can form a chain of these calls. So this is a very powerful idea of what is called a functional, if you will, a pipeline that we talk about. So a functional pipeline is we come up with a piece of data, but we then create a function, let's say F1, and then transform the data and pass it to function F2 and function F3 and so on. This nature of functional pipeline is extremely important to recognize. That's one of the natures of functional programming. But if you really think about it, I would say functional programming really is a combination of two things, if you will. One is functional composition plus the use of lazy evaluation. So lazy evaluation is where we postpone evaluation until we no longer can postpone it, or we don't execute some things because we don't really care about it. This gives us efficiency in the long run. So we are not really sitting there and doing operations repeatedly. And without lazy evaluation, we will have concise code and elegant code, but we won't have good performance. So lazy evaluation is extremely important. So these are some of the really fundamental reasons to why we want to do functional programming, and what are some of the things that are really made in functional programming. In fact, I would say these two are extremely critical for us to be able to do in terms of the composition and the lazy evaluation as well. Those are highly critical when it comes to the benefits we get from the functional programming. So I'm going to say this is functional programming rather than functional style. So functional style may use declarative and higher order functions, but functional programming uses functional composition and lazy evaluation as well. Those are integral part of this particular approach of programming. Well, enough of the talking, but how do we really go from imperative style to functional style? Let me ask you this question. You can answer a yes or no on the chat. So yes, if writing in functional style comes natural to you, say yes, or you find it a lot challenging, say no. What is your observation? Is writing functional style natural? I see no from Abhishek. I see no from Sapan. Rashid says no. So Arvind is an exception, right? Says yes. Well, there are some people who find it natural. For me, it's not natural at all, because the reason really is I am extremely familiar with imperative style. So imperative style is natural for me. Functional style is completely different, right? And I'm like, gosh, how do I think about this when writing the code? It becomes really hard to really think in terms of that functional style. And I'll be absolutely frank about it. I spent a few decades writing code in functional, in imperative style. When I started learning functional style of programming, the worst thing for me was people said it's easy. I'm like, no, it's not. It really takes a different way of thinking, and I'm not used to it. So it's not natural because I'm not used to it. I'm not familiar with it. Imperative style is something I'm very familiar with, so it's natural for me to think about it. So the question is, how do we transition towards that? And over the years, gotten a little bit better at it over and over. And in all honesty, if you give me a problem today, maybe 50% of the time I can think directly in functional style. The other 50% of the time, I'll kick, I'll scream, I'll curse, and maybe find the solution in functional style. In fact, I will tell you one experience I had. I was on a flight from Europe to the US. It was about a 11-hour flight. And I get on the flight, and as soon as I sit down, I open my laptop and I write a piece of code, a particular problem I want to solve. I write it, I mean, literally, I write it in 15 minutes in imperative style. It worked. I have the test in place. I have the code working. 15 minutes later, yeah, this is done. But then I spent literally the next 9 hours on the flight trying to change the code from imperative style to functional style. It was so bad, in fact, the flight attendant came and checked on me a few times and said, "Are you really okay?" I'm like, "I'm fine. It's the stupid code. I'm trying to make it work." And at the end of 9 hours, a little light bulb goes in the head and boom, it falls in place. And you're like, my goodness, why was it so hard to write this code in functional style? Well, the reason is the mind is tangled up on a way of thinking. And it is natural for us to do what we are used to and what we are comfortable with. And we have to really detach from that and ask the mind to think about it for us to be able to write code in a different way. So given that, how do we go from the imperative code to functional style code? So I'm going to take the next about an hour and 15 minutes or so and look at a few different examples. And we will take these examples and look at the code. First of all, it's written in imperative style, and we're going to rework it in functional style and talk about the thinking behind it. How do we approach it? What are some of the things we're going to do? Well, of course, one of the things we need to do is to learn the available APIs. Now, in all fairness, we cannot just dump everything into our head. So it's going to take time to do it. As we work with application, as we work with libraries, as we work with APIs, we have to keep an eye out for these almost constantly and say, oh, look, that function, I didn't realize that function actually exists. Let me think about it and put that in the back burner and think about this along the way and accumulate that knowledge of what's available over time, experiment and so on. But having said that, let's take an imperative style code and try to go into a functional style code and see how that's going to work in this particular case. So what I'm going to do here is to take a little example of a piece of code, which is in the imperative style, like I said. So here we go. So here is a few lines of code. It's a very simple problem, as you can see. We have a function called is prime. And in the main, as you can see, I'm looping from 1 through less than 8, and I'm printing if that number is actually prime. You can see 1 is not a prime, 2 and 3 are, 4 is not, but 5 is, 6 is not, and 7 is. Ideally, we could have unit tests for these things, but at least we have a feedback loop here that shows the execution of the imperative style code. Now, the code here is imperative, as you can see, but what's going on here? Well, you notice you have a variable called Boolean divisible equal to false. And then you have a for loop, and I is 2 to not less than number. And if the number is divisible by that value in the range, then what we are saying here is that we are saying that So is it possible, would you turn off the video because it's distracting due to lagging video, maybe due to lag? Is that be a problem to others? If so, I can turn off my video. So would others want my video to be turned off, or would you want to have it on? Is there a delay that you see? So yes, to turn off, I assume. So I hear from two people. So if you want me to turn off, say turn off. Otherwise, you can say leave it on. Turn it off. Okay, all right, not a problem. I can turn off my video. So so there we go. All right. So so in here, essentially, we are looking at a loop, and we say I is 0 through number, as you can see in this case. And of course, when you see this loop, we're asking if a number is divisible. And if the number is divisible, then we bail out of the loop right away. Well, that's an imperative style code. We tell what to do, but we also tell how to do it. So the question is, how do we really write this in a functional style of programming? Well, in order to think functionally, what I find a better way to do this is, first of all, think declaratively first, and then program functionally. So notice what we talked about earlier. We said a functional style is declarative style plus the use of higher order function. So essentially, in this case, we want to think declaratively first, then we want to program functionally afterwards in our code. So essentially, think declaratively first. So what does it mean to think declaratively? You want to really state the problem as what you are doing, right? So state the problem or the algorithm, right? Or the algorithm in terms of what we do rather than, how to, accomplish it. So essentially, you focus on what instead of the how. So what are we really doing in this particular case? I would say, given a range of numbers from, let's say, 2 to the given, let's say, given number minus 1, we can say then not the given number, right? The given number is a prime number if no number in the range can divide it. So essentially, we are stating the problem as what we are looking for. So, hey, what's a prime number? Well, a number is a prime number if no number in the range can really divide the number given the numbers in the range from 2 to number minus 1, no number can divide that particular number, given number, then it's a prime number. Well, now let's take that idea and now look for functions that can help with those steps in the stages, if you will, of operations. So essentially, you want to focus on the functions that can help you with the stages of these operations. So let's think about what would be possible to do it. So notice, given a range of numbers between 2 to the given number minus 1. So we want a range operation. So once you get a range, what do you want to do? Then no number in the range. So the no number in the range divides the number. So then you look for functions you can use for that kind of operation of none in that range. So that gives us clue as to how we can approach it. So when I run the code, you can see it produces the result. But what I'm going to do now is I'm going to just comment that out for just a minute. And I'm going to say return number is greater than 1. And then I say, I'm going to bring in an import java.util.stream. And in this case, I'm going to first of all ask for an int stream.range from 2 all the way to number. Let's pause there for a minute and discuss this a little bit. There are 2 functions available. One is a range. The other is a function called range closed. The range function, when you provide 2 to, let's say, 10, will iterate from 2, 3, all the way up to a value of 9. On the other hand, a range closed will take the same range, but will iterate up to a value of 10. So you can decide on a function like a range or a range closed. If you really want to cover the last value, you can use a range closed. Otherwise, you can simply say range, and it will stop one shy of the value that's provided. So now we got the range of value. Then we can say none match like so. So the none match basically says, tell me that no number in that range matches the given condition or the predicate. So we take the given value I, and then we say number mod I is equal to 0. Well, that's divisibility, which we saw up here. And we are simply saying, check that no number actually satisfies that. So when you run the code right there, you can see it produces the same result as it did before. And now that we refactored it, we can get rid of the imperative style code and keep it. Now, of course, a few questions may arise in your mind. What about efficiency? Well, efficiency wise, the question is, what is happening in the imperative style code that we saw before? If you provide an even number, then the divisibility with 2 will be satisfied and it will bail out. Even if the number is a very large number, you're not going to be iterating for every single value in the range. It will check for a divisibility with 2 and immediately will bail out. If a value is divisible by 3 and not 2, it'll go through the 2, but then when it checks for the 3, it'll bail out. So the only time it'll go through all the values in the range is only if the number is a prime number. Otherwise, it'll exit pretty quickly. Well, so the question is, that's great. We had that efficiency in the imperative style, but what about the functional style of programming? Well, that's the beauty of the functional style, is that you can enjoy these performance gains as well. So the none match will not execute every single value in the range, but instead, the minute this returns false, it will bail out of the computation. It will not iterate through all the possible values. So as a result, it's pretty darn efficient in terms of its performance. And that is the nature of how the functional pipeline actually works. So that is something we need to think about the pipeline and how the pipeline actually works. So if you take a piece of data and you send a function 1 and send a function 2 and a function 3, let's say, and this is actually a collection of data. So the way this is actually going to work is that F1 is not executed on each value in the collection. So what's actually going to happen? Well, first, F1, F2, etc., are fused into one, complex function behind the scene, right, or under the hood. So it's really fused. This fusing operation actually happens in functional style of programming. Then, the fused function is run on data D1, and if the computation is not completed, then it runs on D2, then on D3, etc. So in this case, when none match returns false, immediately it's going to bail out right away. Rather, the predicate given to none match returns a false, it'll bail out immediately and will not execute the remainder of the functions. And that's pretty darn efficient. Such one of the biggest benefits you get out of this kind of code is that efficiency. So what do we do? Think about a problem, first of all, but think about it functionally. Well, before you think about it functionally, think about it declaratively. And once you think about it declaratively, write it down as a series of steps or series of transformations you would perform. And once you identify these transformations, then look for functions that can do that work for you and simply replace those steps with the functions. So essentially, my recommendation is think, first of all, declaratively and code functionally. And this is something I tell myself quite often, especially when I get tangled up in all the complexities I have to deal with. I remind myself and say, hey, don't worry about the functional style at this point. Think a lot more about the declarative style. Think about what you are actually doing. And once you think about what you're actually doing, then think about how to accomplish it in the declarative to functional style. That seems to be a nice journey. So any questions or comments, any thoughts along the way, don't hesitate to ask questions or make comments along the way. Try to make it as interactive as you can. Abhishek says, the look for functional steps also includes writing new functions. Well, so that's a really beautiful question, Abhishek. Let me spend a minute on that. Now, if you were trying to explain to somebody about, let's say, the nature of, oh, let's say you're explaining to somebody about, let's say you are talking about, structured programming. If somebody asks you, what do you do in structured programming? You say, in structured programming, we have about 7 structures, and we program everything with these 7 structures. And they look at you and say, wow, how could you write every single program using 7 structures? You say, well, you see, we have an if and else as a conditional flow. We have a for or a while or a do while for really performing loops and so on. So as a result, we can simply build on these ideas very easily, and we say that quite naturally. So in other words, we can program almost any application in structured programming by using all these loops, if you will, and if statements and so on. In a similar way, in a functional style of programming, you have things like filter, map, and reduce. And it turns out you can do most of the things with a filter, a map, and a reduce operation quite a bit. And as a result, you are able to really structure your application as a series of these combination of filters, maps, and reduce operations. So do we have to write newer functions? No, we don't have to write newer functions for the connecting the stages. But of course, may have to write newer functions for the implementation in each of the stage. But that's often a domain specific implementation. So the answer to your question, Abhishek, is, do we have to write newer functions? The answer is, it depends. You may have to write newer functions for your domain specific code, but you don't have to write functions for the functional aspect itself, because that's ingrained in the functional libraries oftentimes, and we don't have to really do any work for that essentially. So that becomes a lot easier for us to focus on our business logic, our domain specific logic, but don't have to really be worried about extending the functional libraries themselves. The libraries do a fairly decent job in providing that after all. Okay, so a few other questions that popped up. Let me take a look at those. So the next question I see here is, can you explain how the fusion functions are fused? Let me give you a little examples, about how that's being done. Really good question. So just to understand a little bit about fusing, if you think about this, I'm sorry, I was in the impression I'm sharing my video. I was trying to show a little demonstration here, but imagine for a minute, since I don't have the video on, I'm holding a pen on my hand. Now, if I ask you what that is, you will say that's a pen. But I'm unscrewing the parts of the pen, and now I have about 3 or 4 parts on my hand. Suddenly we realize a pen has a casing, a pen has a holder for the ink. It's got a little clutch, you can probably hear me use here. So there's a different parts to a pen. And in other words, we have this abstraction of a pen, but it's made up of several parts. In a similar way, a function can be made up of other functions. So to understand this a little bit, let's look at an example. So let's say I have a function over here, and now I'm going to say, let's say a public, let's say, well, what do I want to say? A print, and that takes a number, and I take a message, let's say, but I'm going to take a function in this particular case. And this function I'm going to take here takes an integer and returns an integer. And I will simply call this as a func right now. So then what I'm going to do here is to simply say, let's say output, let's say the given number plus, let's also output the message given to us, plus let's say call the function, if you will, apply and pass the number to it. So now if I were to go back here and say I have a function which takes an integer and returns an integer is equal to, let's say, given an element plus 1. I can easily call the print function, pass a 5, we'll call it incremented, and I can then say inc over here. So notice in this particular case, we incremented 5 and it became a 6. That was very easy, if you will. So on the other hand, if you were to write another function, let's call it as a double it. And in this case, I'm going to take the given value and I'm going to double the value. So again, in this case, we can say over here doubled, and I can say double it, right? I want to call that 5 double is 10. But notice what I'm going to do though. I'm going to take the value 5 and I'm going to say incremented, let's say, and doubled. So how do I increment and double? So I say fused, and notice what I'm going to do in the fused. I'm going to say over here, a function will say integer, comma integer, and I'm going to say fused is equal to inc and then. So I'm going to say the doubled, and I'm going to fuse it together. So 5 plus 1 is going to be 6, and then 6 times 2 is going to be 12. And so I'm going to take this over here, and I'm going to fuse that, as you can see, in this particular operation. So essentially what I'm doing here is I'm doing an and then and double it, right? Not doubled. So that's going to be a double it, and I'm going to fuse that with a double it function, as you can see right there. So when you look at this code, we get a result of 12. But this is one idea of fusing. So you can take a function and you can combine that with other functions internally. But the logic is a lot more complex here. So what it's going to do is it's going to say, oh, I'm going to take this and use logic to decide whether to call the next function or not. Similarly, you can combine functions with predicates. You can take two predicates and combine them. If the first predicate succeeds, the second will not be evaluated in the case of an OR. And if the first one doesn't succeed, the second will be evaluated. In the case of an AND, well, if the first one fails, it will not evaluate the second one. If the first one returns a true, it will evaluate the second. So there's logic to combine them. So the fusing happens internally, but that's just an example of how we can fuse functions ourselves. But Java, for example, the JDK API does the fusing quite a bit internally for this to happen properly. So that's one of the nice things is that mechanisms are available for such fusion, and APIs are available to take care of that quite powerfully, if you will. The next question I see here is it safe to say that algorithms are declarative and implementation can be functional? Well, the answer is yes, absolutely, because it really goes, Sapan, the answer really goes back to Turing completeness. And all of these, both imperative, declarative, and functional, are Turing complete. So you will be able to solve any problem. But Sapan, the problem really is not about the possibility or the feasibility oftentimes. It's often about efficiency. There is space constraints, there is time constraints as well. So in some cases, we may find one style is better than the other, not from the feasibility point of view, but from other constraints and considerations point of view. So of course, can doesn't mean should. So we should always keep our minds open, because sometimes an imperative style is better, especially when you're dealing with exceptions. It's a better option to use imperative style. So I wouldn't really go to the extent to say everything has to be done functionally. We need to use the tools and be able to use them properly. Harshal says, what's the difference between wireframing and structured programming? I don't know the answer for that. I'm sorry. So the next question here is, Terrell says, is not a custom function itself is imperative. Well, it doesn't matter, right? And the reason really is, it is called encapsulation. Well, within the encapsulated layer, how you do it is not important. And it might be functional, it might be imperative, it might use recursion, it is encapsulated. You can change it any way you want to. And that's the whole point of encapsulation, isn't it? Encapsulation simply means you can vary the implementation. So when you look at whether it's imperative or functional, you always look at your code at the layer in which you are writing the code, not in the layers below, because that's encapsulated. That might be functional, that might be imperative. An author may write it one way and change it later on, but it doesn't matter for our code because the focus is on the code we are writing. Rohit says, when to write private predicate functions or predicates as parameters. And the answer really is, I would say, reuse and convenience. If you really want to reuse that predicate in different places and plug that predicate in directly into functions, you might really write them as a predicate. But if you really don't need to write them as a predicate, you can just, pass a method reference. Java is, in this example, we're using Java, but most languages are really good at taking functions, lambdas, or taking method references and converting them into predicates. So I would say, if you really want to create a predicate and you want to combine predicates, then create a function that returns a predicate, because you don't have a way to really combine arbitrary functions in Java. If you write it as a predicate, you can combine predicates easily. If you write them as a function, you got to create a predicate and then combine it. But having said that, I would say most of the time I write functions, I don't write predicates. So rely on convenience. If you find that it's really helpful and useful, then and only then use a predicate. Otherwise, simply write a function and you can just use them where it is needed. So it's more of a convenience and reuse more than anything else. Pradeep says, is functional programming is new era in programming? Well, I wouldn't call it a new era. I would call it as a revisited era. Pradeep, I will ask you a question. Is electric cars a new era? And I would say, if you look back in history, in the 1800s, late 1800s to early 1900s, the streets in the US were filled with electric cars. We did not have gas-powered cars. And that only changed in 1920s, and the world dominated with gas-powered cars. And so if we say we are in a new era of electric cars, historians will kind of scratch their head, because electric cars were prominent before gasoline cars. In a similar way, functional programming really were prominent before imperative style of programming historically. So it's just like we are getting re-excited about electric cars, we're getting re-excited about functional programming right now. But I want to really emphasize this. I am more of a fan of a hybrid, if you will, not in the terms of cars, but in terms of programming. And the reason I say that is, we don't want to get stuck on one methodology. I don't like dogma, right? It's important to be pragmatic, and we want to be able to pick and choose what may make sense. So it's perfectly okay to mix and match the paradigms where they may make sense, rather than trying to really tell ourselves that only one way of doing things is the right way. The next question I see here, really good question. Thanks for all these wonderful questions. Good points. And I'm trying to really, look through these messages of, somebody temporarily joining and unjoining. If there's a way to disable that message, it'll really help, because I have to really scroll up and down to find the messages, and I'm losing sight of where things are. So I apologize for taking the time to find this. And as I'm scrolling through, it just scrolls away. So I'm not able to find some of the questions. So I'll answer as many as I can find, but if I don't answer your question, please post it. I think I answered some of those. All right. So I think I talked about the new era of programming and what I think about it. Let me see if I'm able to get to the next question. It scrolls through. Unfortunately, it's hard to find it. Okay, so dealing with exceptions in functional pipeline. I won't spend much time in this talk on exceptions in functional pipeline because that's not the focus of this talk. Maybe another time we can spend the time on exceptions. If we have time in the end, I'll talk about it, but I won't promise right now because that's not the central focus of this topic. Are we going to fully automate? Are we going fully automated by functional programming? I don't know what that means, Harshal, because automation has nothing to do with functional programming. It's completely, orthogonal to it. You can automate in anything you do. It doesn't have to be functional programming. So sometime when we write, when we try to convert imperative to functional code, or we use recursion. No, we don't have to. Recursion is not necessarily a functional programming concept. Functional programming languages often use recursion, but often confused idea. So we don't need to use recursion. In Scala, there are some optimizations for recursion. Yeah, I would say that's not really a relevant topic because functional programming is really orthogonal to recursion. People often get confused. Functional programming languages often offer a tail call optimization, but that's really not related to functional programming itself. It's more of an interesting side idea. So I'll keep the focus here on functional programming. So sometimes when we try to convert imperative to functional programming, so I think I answered that question already. And I think there's a repeat of that multiple times. So are streams slow as they perform some tasks under the hood? No, it really is a question from AA, and it's really a wash. They're not really slow. One of the things you want to often look at is not a raw performance, but you want to often look at the time and space complexity. And the time and space complexity of imperative and functional programming are one and the same when the language or the API or the library implements lazy evaluation. So when they implement lazy evaluation, you are getting the same space and time complexity, so they are not inherently slow from that point of view. If you were to look at a raw speed, you may see a difference, but we rarely really care about raw speed. We often focus on the complexity, and they are in the same complexity frame in general. And I'll take one more question before I go to the next refactoring. Does writing code using imperative and functional make difference in time complexity of the program? You actually heard my answer just a minute before I read your question. No, they have the same time and space complexity. That's one of the beautiful things, if you will, that becomes really beneficial in terms of how we can write this for efficiency as well. Great, good questions. I really appreciate those questions. Let's move on to the next topic. So we saw the example we just saw. It was less noise, no garbage variables. Garbage variables often are variables that really are used for solution purpose. They're not needed to solve the problem itself. And of course, we use higher order functions as well in this case. Let's move on to the next exercise here, where we want to talk about the counting the number of lines. Let's see how that actually pans out. So here is an example. As you can see, what I have done here is when I run the code, you can see it says the word localhost occurs 3 times, it says. Okay, but what's happening in this code? You can see this imperative style code is saying in this particular case that the localhost is a search word, as you can see. Then it says the path is etc. host, as you can see. Then it says count to 0. It opens up the file, and then it says null, which is a smell, right? Null is a smell, and we are using the null right there. And then we are saying, while the file read line is not a null, the line is not a null, then we take the line and we compare to see if the line contains a search word. If it is, we increment the count. And then once we increment the count, when we finish the loop, we are printing the details out. So the question really is, how do we really think about programming this in functional style? When you look at this code, what are we doing? Think about the act we are doing here. So open the file, and for each line, check if the search word appears, and count a number of lines that meet the above criteria, right? So basically, this is what we are doing. So if you think about this particular problem, open the file, for each line in check if the search word appears, count the number of lines that meet the above criteria. So now let us think of this as a functional pipeline. So I need, I'll quickly look at some questions to make sure I don't miss them. So what's the difference between functional programming in Java and Scala? There's no difference. They're just different sets of API. It's functional programming all over. They both support functional programming. The next question here is, what are the, so the next question here is, I really apologize. I'm having a hard time keeping this window stable with all these messages that keep popping up. So what are the benefits of any code? So what benefit any code can get with help of lazy evaluation of expression? Sumit, let's postpone that question. If I don't answer the question by the end, please ask that question again and I will answer it, but we'll cover that along the way. Gulshan says, will time and space complexity of imperative function be the same? I answered the question already. The next question here is it recommended to write optional in stream over null check? In general, if you're able to avoid null, I think that's a better programming practice. So as much as possible, I will refactor my code, Rohit, to avoid nulls as much as where I can. If you want to return an optional, that's better. But if you can even avoid that situation, that's even better. But definitely go away from null as much as you can. So which one is better, lazy evaluation or the way to program? And what is the benefit of using lazy evaluation? Again, I'll talk about that later with an example. If I don't answer that by the end, please ask me. And so I think the messages are just scrolling back up again. So I'm reading them as it bounces by. Okay, so now that we talked about this, one question is, what is IIFES? Google for it, Anuja. That's the easiest way to find answers to such questions. All right, so let us talk a little bit about this. Think about this particular problem right there. So folks, keep the questions relevant to the topic we are talking about right here to the examples, because otherwise I won't be able to focus on the topic at hand. So any general topic like comparing Java to Scala, don't bring those up here. We want to focus on the topic at hand. So focus on this and not on broader topics. I really want to focus on the topic at hand. Okay, so again, I talked about functional and imperative styled Rushian. So I want to continue forward right now, not keep going back to what we already talked about. So here's a question for you. Let's think about the functional pipeline. What do you think are the functions in this pipeline that you will be talking about when you will be thinking about when it comes to this particular problem? So think about what would be the functional pipeline. What are the functions you can think of at a high level? Can somebody answer that question? What are the functions you can think of at a high level for this problem if you were to formulate it as a functional pipeline? Remember, we talked about the predominant functions of functional style of programming. So what are the functions that come to your mind when it comes to this particular problem? If you think about this problem of taking a file, bingo. So Ruth says map and filter and open the file as a stream and conditional check, a filter again, bingo, right? So filter is the predominant function that comes to your mind. You are absolutely correct. So in other words, if there is a way to get a stream, if you will, of the lines from the file, we can then use filter and reduce. So you want to think about filter and reduce, not as much of a map, but a filter and reduce. But keep in mind, reduce comes in many flavors. There are some what you can call as some really specialized reduce functions. So you hit the nail. That's exactly what you want to do. You want to think about it as a series of transformation. A filter and reduce comes in really handy. So if you look at this right here, you can see that the code is executing and produces the result. But what am I going to do now? I'm going to do exactly what we just talked about. So notice, I'm going to go back to this code and say long, let's say count is equal to, and I'm going to first of all say java dot, let's say nio dot file dot star, and I'm going to say in here a files dot star, and I'm going to say files a dot, and I'm going to say in this particular case, I'm going to say lines. And then I will ask for, actually, you know what? Let's take baby steps towards this. So let's go back here and let's get the file content, if you will, to begin with in this particular case, and then work our way through and see how that actually works. So let's go back to the code and let's go ahead and say that we want to take the count of 0. Let's start with that. But let's look at the files, if you will, and see how that's going to manifest itself in this particular case. So let's go ahead and say, let's just bring in an exception for now. And let's go to this code and say, I want to bring java dot, let's say nio dot file. And let's say in this particular case, let's go ahead and say output, let's say files dot lines, and we'll say paths dot get, and we will provide the path over here and see what it provides for us. Notice how it gives us a pipeline, a functional pipeline. So essentially, if there's a way to get a stream of the lines from a file, that's exactly what we did. We got a stream of lines from the file. Now that we got the stream, what is the next step we're going to perform here? We can now say a dot filter, as you suggested. And what are we going to do in the filter? In the filter, we say, given a line, we can say line dot contains the search word, and we can ask to see if the search word exists. Then I say a dot and count is really a reduce function. That's what we're going to use. So this, of course, is a filter, as you can see. This, as you see, is a reduce function. It's a specialized reduce. That's what you're bringing in. Mitch says read file store in array apply. Okay, I think that's a little bit of an obsolete response to the question that was discussed earlier. So essentially, in this case, we are using the approach you suggested, which is to think about the filter. So it really becomes a filter and a reduce operation, and you want to think of these transformations through the code. So essentially what we did here is we got a stream from the file, and then we filtered out the lines that contain the search word, and then we performed a count on it to see how many lines of code have that. Obviously, in this case, we are looking at the number of lines that have it rather than looking at the number of instances of the word in general, and that's basically what we have looked at in this case. So good. So we looked at an approach. So what did we do? We did not use any explicit mutability in this code, so we're not constantly incrementing the count. So what is the benefit of not mutating? What is the benefit of immutability? There are two benefits specifically. One, it's easier to parallelize the code because there is no shared mutability, there are no race condition. So one benefit of no mutation is easy to parallelize. Functional code is generally easier to parallelize. And so is immutable the main goal of functional programming? Not at all, Pankaj. It's not the main goal at all. The main goal of functional programming is to reduce the accidental complexity and make it efficient. So I tweeted this a few weeks ago. I mentioned that immutability is needed in functional programming, not because it's fashionable. It is needed because it's needed for performance and ease of parallelization. So you can parallelize easily. Secondly, if you have mutability, you cannot do lazy evaluation. So functional programming relies on lazy evaluation. With mutability, you cannot do lazy evaluation and get correct results. So going back to your question, Pankaj, functional programming relies. So here's a way to think about it, right? So to answer that question, you want to think about it this way. Functional programming relies on lazy evaluation for performance and performance. Lazy evaluation relies on immutability for correctness. So hopefully that correctness. So hopefully that answers your question, Pankaj. Is we functional programming is not bent on immutability. Functional programming wants to give us good performance. So it relies on laziness for performance. Lazy evaluation relies on immutable correctness. So you can say functional programming, relies on immutability. So in other words, this is the reason, right? When people say, oh, you got to make things immutable, the question is why? Because we want performance, and performance relies on lazy evaluation. Lazy evaluation relies on immutability to provide the performance. That's the reason why we need to provide these, not because of some dogmatic rules. That's the reason. So what we solved in this problem was we used a stream and we performed a filter operation on it as well. And that's basically what we did in here. Well, let's move on a little bit further to the next problem, which I think you would agree is very verbose when you look at it. So let's look at the code and see what it shows. Notice in this particular code, I have a main and I have a map in the main, which is an empty map right there. And to the map, I've added a bunch of scores. So we got a bunch of names and a bunch of scores. Then I call a function called get group score, group by score, and provide the scores to it. So when I run the code, look at the output. It says 11 is the score, and Tom and Nancy have that score. 12 is a score, Jack has it. 15 is a score, Darla, Nick, and Jill have it. So how do we really create this code? This is the imperative style, as you can see. But what are we doing here? So notice we first created an empty map like so. Then we said, hey, for every score, for every key in the particular collection, we get the name. Once we get the name, we get the score for the name. Then we create an array list, which is empty. We check if the Y score already contains the score. If it does, then we take the score given and we get all the names that are already in the collection. Otherwise, we got an empty collection. Then we add the new name to the names already there for that score, and then we put it back into the collection. And then we return the collection. This is pretty darn imperative, as you can see. So the question is, how do we really make this functional? So the question is, how to program functionally for this. So let's think about this, right? Let's think about this and see. So what do we have? We have a name and a value, right? A score, right? So this is what we have: name and score, name and score, name and score. So what do we want to do is we want to get the result where we have score and we want to contain names for that score, right? This is what we want as a result. So what we have is name 1 and score 1, name 2 and score 2, and we have a name 3 and maybe a score 1 again, right? So basically that's what we have. What we want as a result is we want score 1, and then we want score and the name 1 and name 3, and we want score 2 and we want name 2 in it. So let's think about how do we approach it. Well, imagine for a minute that you are working with a group of children at home and you want to keep them active, you want to keep them busy. Maybe this is the day they are home and you don't want them to bother you as much, and you have stuff on the floor and you want them to organize it. And maybe you want to organize it based on colors of things on the floor. So what would you tell them? So a lot of times it helps to think about the problem a little bit more visually. Think about it not as a code where you're writing some code and you're writing some functions. Instead, step back and think about it as a logical problem you're trying to solve with the physical things around you. You got a bunch of children, you got toys on the floor, maybe you want them to clean it up. How would you tell the children to clean it up? You don't want them to take everything and dump in one corner. So you may tell the children, children, here are the toys. Based on the color of the toys, put them in different buckets. So think about buckets. So think about buckets. So then you say, we will put a name into a bucket, with the score, right, for that name. So for that name as a label. So essentially, think of this in terms of buckets. So if you think of them as buckets, you want to perform an organization or a grouping where you're going to put stuff into a bucket based on the score. So it turns out streams collect, has a way to group based on buckets. So this notion of bucket can be really helpful to think about. So going back to this code, now let's think about this problem in terms of the buckets. So let's go ahead and comment this out for a minute. We'll come back to this and see how we are going to do this. So we will bring in the stream first of all. Then we say in here, we're going to say, we will say, first of all, return, and we have the names given to us. But in this particular case, you want to really take each of the name in the collection, right? That's what you want to work with, the names in the collection. But what you want to do is you want to group it, but you want to group it based on the bucket, right? That's what you want to base it based on the bucket. You want to perform the grouping. So in this particular example, what do you want to do in terms of how you would group it? So you're going to say, I want to first of all work with the key set like we did before. That's exactly the same thing we're going to do here. So we'll say return, and we're going to say that the scores dot, so scores dot will say key set, right? So we're going to bring in the key set. But then we say a dot stream. So we got the stream on our hand. Then we say a dot and do the collect function. So the collect function is really a reduce operation. So then we say we want to bring in the collectors into the mix. We can go to the collect function and we can say in here a grouping by. So grouping, let's say grouping, a grouping by. And what do we want to group it based on? Given a particular name, we want to say scores.get for the name. So what are we specifying here? We provide the label for the bucket. So that is basically what we are doing in this particular code. We provide the label for the bucket. Notice the output. 11 has Tom and Nancy, 12 has Jack, 15 has Darla, Nick, and Jill, but we provided the bucket. So when you think of this as a notion of a bucket, so we are saying, go to each of the names in the collection and group the date details where given a name, get the score for the name, and the grouping by says, I will put that into a bucket where the label of the bucket is the score that you provide. Now, a little bit of refactoring again, in this particular case, you can use a method reference like so. So you don't have to work so hard as we did before. We can use a method reference for the purpose. So essentially, you want to think about this again in a very high level declarative way. I often think about this like children working in a messy room, and you tell the children, hey, based on the color, put them into a bucket of that color. I got a green color bucket, I got a red color bucket, and you tell the children, take all the toys which have green in it, put them in a green bucket, take all the toys which have red in it, put them in the red bucket, for example, and you're asking them to group it based on the buckets. This notion of grouping based on a bucket is a very powerful concept. And then once you click that in your mind, it's a question of finding functions that can do the work for you. And keep in mind that collect is a reduce operation. So again, this notion of filter map reduce keeps coming back here, even though they look different on each of the particular calls we make, it looks a little bit different. So how do we solve this particular problem? Well, it's very highly expressive. It's declarative. We're using specialized functions like collect and grouping by, and we are able to solve this particular problem. Now, given this, of course, we're going to up this a little bit for the next about 10 minutes. We're going to go to something a little bit more complex for us to understand. So in order for the next one to understand, we got to set some context in this particular case so we can deal with this a little bit better. So let's go to the next example here. Now, this one is a problem that actually somebody emailed me and said, hey, I've got this example. How do I make this work in functional style of programming? And in this particular example, we have a main function where we say compute triples. And a triple really is given a value A, B, and C, well, A square plus B square is equal to C square. So that's the combination of values we are looking for, where A, B, and C form this triple. A square plus B square is equal to C square. So how do we really provide that particular functionality? So when you notice over here, you have the A, B, and C are the values we compute based on a given M and N. So we start out here with compute triples. So if you look at the compute triple, what does that function really do? It takes a number of value, but notice in here, you have a empty array list, a count of 1, M starts at 2. This is a specific algorithm given by Euclid. It's called the Euclid's algorithm. And notice that it starts with the M of 2 and the N of 1 to a value less than M. And we call the get triple, and we add it to the triples and we count it. If the count is greater than the number of values, we break out. And again, we break out of the loop. Kind of a messy code, as you can see, right? But the get triple is good. It just given an N, M, and N gives you a triple. So when you run the code, you can see those are the values that you see for 10 values. So the question is, how do we compute it? Before we answer this question, let's talk about map versus a flat map. So this is a bit more complex than what we have seen before. So if you have a 1-to-1 function used map. If you have a 1-to-many function used flat map. So a flat map actually maps the values into a collection and flattens the collection. So that's why it's a flat map operation. So you map it and you flatten it. So this turns out to be a very interesting flat map problem, as it turns out in this particular case. So let's understand how this is going to manifest itself in this particular case. So what you want to think about is a series of transformations and a flat map operation. So let's get down to it. How do we implement it as a flat map operation? So if I go over here, this is the compute triples, and I'm going to get rid of all that code, and I'm going to say a return stream.iterate. And starting with the 2, given an element plus 1. For those of you asked about lazy evaluation, just stare at that function for a minute. What does this iterate say? It says start with the value of 2 and keep computing E plus 1, E plus 2, E plus 3, E plus 4. So 2, 3, 4, 5, 6, 7, keep on going. Well, how could you possibly create an infinite series? It's not practical, isn't it? So that's got to stop at some point. Well, the answer is lazy evaluation. So lazy evaluation gives you performance, but lazy evaluation also makes it possible to implement infinite sequences as well. That's one of the benefits of laziness. So here you have this, a stream, iterate, then you do a flat map on it, and you take the value of m, and then you say into stream dot range. You go from 1, but one value less than m, remember? Then you do a dot map to object, and you say, given a n, get triple for the m and n. So this says, I'm going to keep going for all the values that you specify in this particular collection. Then finally, we say a dot limit, and then the number of values we are interested. So the limit is also lazy, but the minute the number of values has been generated, it'll terminate the iteration. And then we say dot collect and to list, and we create a list at this particular point. Let's go ahead and say import java.util.stream.star, and we'll bring in the collectors here as well into the mix. So when you run the code, it's the same output as we saw earlier. But what did we do in this particular example? Like I said, this is a little bit more advanced, but you take the iterate and you create a stream of all the m values. Then for every given m value, you get the triples for the values of n, which is 1 to 1 less than m. But because that itself is a collection, you are going to do a map, a flat map, because it's a one to many, right? For every value of m, you get many values in this case. So we use a flat map. Then we limit to the number of values, and then we collect it. And so again, the filter, map, and collect, but and reduce, the filter, map, and reduce, the collect is the reduce, the map is a flat map in this case. The limit actually is terminating the a collection at this point and giving us the result in this particular case. I see one question here. Let me see if I'm able to get to that question. So so essentially, all right, I need to realign my screen. So give me a second to. All right. So when I scroll up, it just shoots up to the top, and I lose track of where the messages are. So if the organizers have a way to actually shut off those join and depart messages, that will be really helpful. Maybe make a note for the future, because it
Yeah.
really makes it hard to look at the messages. Or if somebody
Yes.
knows the last question, you can read it out for me as well.
Sure. So I think, Venkat, we can do that. Unfortunately, we were looking at the settings. The organizer team is looking at the settings and they're not able to find it. But definitely, I think as the questions will come, Hardik can ask you those.
Okay, thank you. So the question here I see, I think this is the latest question is, it says reposting Prabhakaran, when filter is based on nested list object stream pipeline broken to imperative style. For example, you have a stream and you have a map and a list and a flat map. So if present, we cannot have a list here. Is there a better way to handle with only streams? It's a little bit dense for me to think about at this point, but here's what I would suggest, Abhishek. If you're keenly interested in that question, my email address is right here. I will also post my email address on the chat as well. If you can send me a little bit of a sample code with unit test, I'll be more than happy to show you how to refactor it. So that's what I would say. It's a little dense for me to read at this moment, but if you're keenly interested in that, that's my email address. Drop me an email. I'll be more than happy to take a look at it and show you how we could probably solve that particular problem. All right.
Sure. And Venkat,
So Uh-huh.
In order from have you read or save you from reading the message, I just decided to ask you one. If we were to look at the code that was on the screen just a few seconds back, I just wanted to ask: is it just me who feels that I still prefer imperative, or this we really feel that this actually is more readable than what it would have been an
Yeah,
imperative
yeah,
style?
it's just you, absolutely just you. No, just
Yeah.
kidding.
Oh,
So yeah, that's a very fair question, very fair question, and don't discount familiarity, right? So when I started programming with this, I felt the same way, and it takes a while to get used to it. So the reason I like this is, if you look at this, here's how I will read it. Given a list of values from 2, so list of values 2, 3, 4, and so on, I want to transform to a collection of triples. And then I want to only get those many values and put them in a list. So you want to read the forest from the tree. And once you read the forest from the tree, you want to really get a grasp of the steps you take. So if you think about the Euclid's algorithm, this one very directly represents it, because the Euclid's algorithm says for a given a collection of values, m and n, you can find these triples, and you are basically saying for the range from 2 to as many numbers as I want, I'm going to just, for every given value, I want to compute all the values. So it is a familiarity thing. So when you are not comfortable with this, when you're relatively new to it, as I was, it takes a lot more effort. It's intimidating. This is human nature. We feel like, oh my gosh, this is threatening. It's different from what I know. In general, though, once you understand the semantics of functional pipeline, then you start reading the forest from the tree. You don't dive into each of the function. You ask the question, what does each stage do? And then you combine the stages together to find what the process is. And that becomes a lot better way of thinking about the functional pipeline. So if you feel intimidated, be assured it's very natural. And once we get familiar with it, it becomes easier over time. So don't feel like, oh my gosh, I got to fall back on imperative style. You probably don't remember this, but the first time you started reading code, you felt the same way, I'm sure, because you're like, oh my gosh, what does programming mean? I don't know what programming is, and this all looks very strange. But after programming for a year or two, it became very natural. We cannot take it lightly. Familiarity is very important for us humans because we thrive on that quite a bit. So that example showed us the power of flat map and lazy evaluation quite a bit. But this is going to only shine in the next example we're going to see, where we're going to use infinite series and lazy evaluation as well. So let's dive down to the next exercise and see how that's going to work. So here is the next piece of code you can see. We have a e is prime, but this says compute sum of square root of primes from the start to the count. So compute sum of square root of primes, right? That's what it says. Compute sum of square root of primes. You have a starting value and you need that many values. So if you look at this code, when I run, it gives us a result 770 dot something. We start with the 101 and we are computing a total of 51 values a sum for. But when you look at the code, what are we doing here? The index is equal to start, then compute count is equal to 0, sum is equal to 0, while computed count is less than the count. If it is a prime, take the square root and add to the sum, increment the count, and then increment the index outside of the loop. I would argue this is quite complex, right? It takes effort to read. It's not very natural. But what are we really doing? Let's put that into words first. What we are doing is, given a start, get all the numbers from the start. That's the first step. Then what are we doing? The next step is, if the number is prime, right, then compute the square root, right? That's the next step. Then what are we doing? sum the square roots. Then the last thing is compute for only count number of primes. So this is basically what we are doing is we are counting it for those many number of primes. That's what we are doing. Now let's put all that together in the code, if you will. So how are we going to do this in the code? So we can simply say all this junk we wrote here, right? That's so complex for us to deal with. We don't have to really endure that logic or endure that pain. So instead, what we can simply say is that we want to, first of all, let's take the very first step we have in this particular computation. And every single step, let's think about it. What's the first step? Given a start, get all the numbers from the start. So stream.iterate, and given a start, get me all the numbers from the start. So that takes care of that line that you see right there, right? We took care of that. So the next step is if the number is a prime number, we know exactly how to do that, right? Filter, right? Bingo, as Tejal says, use filter. So you say take a number and you simply say, is this a prime number? So is prime, great. Then what do we say? We say map to double, right? So map to double, and we say math square root. So that's the next step, compute the square root. Great. What's the next step we want to perform? We want to say compute for only the count number of primes. So we say limit this to the given count. And then finally, a sum operation for the sum that we want to perform. That's the last step. So we took the steps we identified and we simply rewrote it as those steps really. But when you look at it, notice this particular code we just wrote, and this goes back to an earlier question that was asked, isn't it? So let's go back to the code we saw earlier, if you don't mind. So let's put this back in here to what we saw a few minutes ago, if you will. So when you look at this code, and I want to put this code up here, and I want to put this code down here, and I want you to compare the code in the top to the code in the bottom, and you can decide which one is more expressive, right? So notice in this case, we are writing the imperative code, which is familiar. Here we are saying, given all the numbers from the start, get me only the prime numbers, get me the square root, but get me only the count number of them and sum it, right? So the second one is more natural, as Ruslan says. Yeah, and that is really hard to write in the beginning, but becomes easier once we are familiar with. And so that's where the complexity is being reduced by the code immensely, as you can see in this particular case. So that's the benefit you get of this particular refactoring, is that you're able to enjoy this benefit of functional style, where you have reduced accidental complexity in the code. And that's the real goal, is to make the code easier to maintain, easier to improve, easier to optimize as well as time goes on, which is what you're really after. So with that said, we got about 4 minutes with us. I'm going to read out one question I see here, and then I'll take more questions as well. So true, it's hard for some who have been coding in Java since 4, but imperative coding opens door to understand other languages having imperative style like Scala. Well, in general, though, the paradigms are harder to grasp. Going back to Gayatri's comment, it's important to keep in mind that a paradigm shift is hard. It's hard for every one of us. I'll be lying to you if I said this was easy for me. No, it was a journey that took effort, but invest in that, right? And take time. Over time, it becomes a lot better. Prabhaharan says, any benefit on prefixing function methods with static keyword? The only benefit is when it doesn't deal with state, you don't have to create an object in order to use it. That's the only reason, right? If a function, in fact, it's a bit of a downer. If you program in language like Scala and Kotlin, you can write functions that don't belong to classes. Because in Java, you cannot write functions that don't belong to classes. If you don't have a state, unfortunately, static becomes necessary. How can I improve my coding skills, says MD? One of the best ways to improve coding skills is to really be critiqued. You want to write code and you want your fellow programmers, others in your team, to review it for you. That's a great way to improve. I want to chime in the words of Newton. Newton said, I see farther because I'm sitting on the shoulders of giants, he said. That's one of the most important things you need to think about, is that you want to really learn from the collective wisdom of others. So don't be shameless. Don't have courage. Don't hesitate. Write code and go to your colleague and say, hey, can you please look at this and tell me how I can improve it? That's a great way to learn. Also learn from reading other people's code. You see they have done things differently and you say, that's interesting, and try to understand why they have done it differently. Abhishek says, what tool are you using to show the standard output and the pop-up? Is it a Vim plugin? It's a combination of a lot of tools I've put together. It definitely is VI I'm using, but I'm also using a bunch of shell scripts in the back and other tools that pop up. So it's a hodgepodge of tools, custom tools put together to get this working. Akash says, as a beginner, which method to follow? As a beginner, it's really important not to get stuck in one method. It's really, really important for us to know that there is no one way to solve the problem. Akshay, to go back to your question, one of the I also teach at the University of Houston, and about 15 years ago, I went to them and I said, I want to be able to offer a course, and they said, you do whatever you want to do. I'm really grateful for that. They gave me the flexibility, and I decided to offer a course called Programming Languages. This is a course I teach at the 4th year student level. And my goal for this course was the students should come out learning that there are many ways to do things and there's no one way to do. In the programming languages course, we do 20 languages in the course. And it's an extremely intense course. But by the end of the course, the students come out realizing there are multiple ways to do things. I don't want them to be an expert in one way. I want them to know that there are different ways of thinking and we should really explore multiple opportunities. So as a beginner, which one to follow? Follow the path of knowing there are multiple ways to do things and not just one way of doing things. That is extremely critical. Goes back to Thomas Huxley's words. He said, learn everything about something and something about everything. So diversify your knowledge portfolio. That is extremely important. And Abhishek says, I love functional programming now. Thank you. I'm glad you're finding it useful. And Ganga says, thank you, Venkat, and organizing team. Thank you. Yes, absolutely. Thanks everyone for showing up and being part of it and participating. Thank you so much for the organizers. Wonderful effort. I really appreciate it. Thank you so much for joining. I think you're on mute.
My bad. Yeah, I think there was one more question by Sia, and she was asking if we can take that university course that you are teaching without joining the, like, is it available online?
No. Okay. It's only at the university. Yeah.
Let's see. All right. Thank you very much for spending some time with us. We tried really hard to figure out an option to disable these notification messages, but it seems like we couldn't on this Teams platform. So maybe next time onwards, we might use a different platform. Apart from that, really enjoyed your talk. Even though I was familiar with functional programming concepts, this was really beneficial, and I think everybody else feels that way, considering all the thank you messages that are spawning up in the chat. Yeah, I would also like to thank all the participants, especially those who participated in the question and answer sessions. At Software Craftspeople Community, we'll continue to organize this kind of events and look forward to those in the future. Thank you, everyone.
Thank you so much.
Thank you, everyone. And thanks, Venkat. That was really amazing, hands-on, power-packed. So thank you so much for doing this.
Thank you.
Everyone, thank you for joining. And if there are ways that you would like to contribute towards this community, please reach out to us on Meetup. We would love to hear from you. I'm going to paste the links to where you can find a recording of this talk and all of our past talks as well. So please go ahead and take a look. Thank you very much.
All right. So thank you so much for having me. I'm going to disconnect. So appreciate all the effort, and we'll meet some other time. Thank you.
Absolutely. Thank you, Venkat.
Thank you.
Thank you.